Good morning, ladies and gentlemen. Welcome to another installment of KETIV Autodesk Virtual Academy. The date is June 10, 2021. Welcome. It's a great day outside. We have some fantastic summer weather here in Southern California. And we do have a special guest here today, Marco Trinidad, who's in NorCal, which I'm not sure what the weather's like up there, but Marco, when you're ready, go ahead and turn on your camera and microphone over there. We got a lot of interesting stuff here to talk about today. Marco's going to be actually his first time here today with AVA, so give him a nice warm welcome, everyone. How you doing, Marco?
Hi, it's doing good. The weather is a little colder today in the morning, but Bay Area weather is usually like 3 different kinds of weather throughout the day.
Yeah,
Start
absolutely.
out cold with a sweater and then just warms up for the
I was
rest of
going
the
to
day.
say, yeah, it's going to get hotter this afternoon, and I'm not sure if I'm going to
Yeah.
appreciate the SoCal weather as much when it hits 3 o'clock today. But yeah, thanks for joining us today. I know we're going to be talking about some interesting stuff here. This is a topic that has, it's not necessarily like the most explicit topic in Inventor, I don't think, but it's an interesting part of the program that ends up feeding into a lot of different workflows and aspects for sure. So I'm excited to have you over, Marco. I usually like to ask my guys about some interesting facts. I hear you shoot photography. Is that right?
Yeah, so I'm pretty big into photography. I was freelancing a little bit before
Oh, nice. Yeah.
joining KETIV, but yeah, it's a pretty big part of my life. And then you're going to see through this presentation, I'm going to show a couple of parts and show them inside of Inventor and how we could use today's feature with them.
Fantastic. Yeah. So, well, I'm glad you're here to guide us through another guiding aspect of the program, user coordinate systems. Before we get on our way, just a quick reminder that this is a Zoom webinar session, so you're free to interact with us via the chat or Q&A section. So feel free to submit questions accordingly. Interaction is highly recommended, so feel free to ask any questions you might possibly have. There's going to be some poll questions that show up on the screen as well, and if any feedback that you may have about the session or anything else like that, feel free to respond to the survey at the end of the session as well that you'll be receiving via email. Okay, I'm going to hand it off to you, Marco. Go ahead and take us away on this new journey here.
All right, thank you, Adam, for that introduction.
All right, good luck, man.
Like I mentioned, we're going to be talking about user coordinate systems within Inventor. We're going to be showing it both inside of parts and how you could use it inside of a part and inside of assemblies. So moving forward. So we're going to start out with the default settings and how kind of Inventor sets up your origin. And that's going to help us move on to understanding how we could use it within our features and within our assemblies. So moving forward, we're going to start with UCS, how you can use it, how you can place it, moving on to how you can place it within a part, within an assembly, and using it for a constraint. And then finally, wrapping up with how you could use it to set a Z-up coordinate assembly or just reorientate your assembly. Now, a little bit about myself. I'm an application engineer here at KETIV. I started not too long ago and have been working mainly with installation and licensing. I graduated here in the Bay Area. I've been here my whole life. I graduated from San Jose State University with my bachelor's in mechanical engineering, focusing in design. And like Adam mentioned, I am a big photographer outside of KETIV and outside of my professional career. I did freelance for a little bit, and a couple of the parts that we're going to be looking at today are actually photography parts that I use and I have to show you. So we're gonna start off with when would you use a UCS, and overall within an assembly you could use it for a constraint, both to constrain just your parts, as you can see in this slide, and also to constrain your assembly to a new coordinate system. As you can see in that bottom image right there, we have a Z up coordinate system. Other uses of outside of just within your assemblies are parts without features. If you have a part that doesn't necessarily have defined features like a new part would have in Inventor, you can go ahead and still create UCS within that part and use it to constrain it. And you can use it to reset the origin, because I know it's not, if you're don't have a standard for your origin, people can be setting it to different parts of your, to different areas of your parts. And that is how it is helpful, at least within parts and assemblies. So today, one of the things we're going to be looking at is how we can use that within this part. You can see it back on this slide, this little doohickey that I have right here. It's actually a camera handle that I have right here, and we're going to go ahead and constrain it and add some features to it that aren't in the initial part designs that I made.
Sorry, let me
Yeah.
stop you right there. Could you go back to the previous slide here?
Yeah, of course.
So just a quick note, yeah, I don't think we had a poll slide over here. My apologies, but I am kind of curious, just for the audience, kind of curious who is using UCSs, and I'm curious, possibly what industry you're from. UCSs are kind of an extension of the general work features inside of Inventor, of course, and so there's you can kind of consider it like it's a good way to help orient and kind of add in additional references. And that could mean different things depending on what industry you're from, of course. There's some talk about like BIM export or BIM content exports. We get some questions about CAM, which isn't necessarily related to this, but we could talk about that as well when it comes up later. So just kind of curious what the crowd is like over here. And if you guys have any particular applications of UCSs, I'm really just kind of curious what you guys are using it for, if anything. And so if you want to put that in chat, I'd love to hear about what you guys are doing with UCSs inside of Inventor. All right, I'm going to cut the poll there. And so, yeah, we got an interesting split over there. I'm going to share these results really quickly here. You currently use UCSs? Yes, about 40%. No, about 60%. Interesting. And what industry do you work in? Architecture, minority over here at 14, and then product design at majority 81, which possibly expect for sure. Yeah, and so again, like, coordinate systems in general have a variety of different applications, whether you're talking about, CAM, and they might be called like world coordinate systems or universal coordinate systems, or AutoCAD. Civil 3D uses a lot of coordinate systems and stuff like that. And Marco is going to be talking about Inventor's applications in particular, but that's an interesting spread for sure. Okay. Okay. And yep, sorry, I'll hand it back to you there, Marco. Thank you.
Yeah, of course. All right. Go ahead and move forward. So we're going to start talking about what the default origin. So with the default origin, you do get your 3 axes, you get your 3 coordinate planes, and then you get a point for your origin point at 0, 0, 0. All of those carry on over to custom coordinate systems, where you get all the same prompts and you're able to use those within your model. And then you're able to use those additionally within the assembly, in addition to your origin created within your part. And you can use that. I think I'll move over to Inventor now, to sort of show you how you can place it and what kind of goes along with placing it within your part. So I'm going to start with going into the part. Create a new part, and I'm going to show all of my planes right here, which I'm on to physical, and then orientation. And I'm going to create a sketch to show you how you can place it within a sketch. And do a simple cube here. One, and then finish here. And extrude this up 1 inch. So you can see your UCS work feature right here at the top on your ribbon. When you place it, it's going to prompt you to do 2 things. It's going to prompt you to select your x-axis. Now, if you're out here where there's no point, if you click enter, it's going to place it, and you don't really get much more than that. So what you can do is when you go up here to see your parameters, you could set it to 0, and every UCS creates 6 parameters for placement. 3 of them are going to be translational for your X, Y, and Z, and then 3 of them are going to be rotational to change the axes. And you can see if you place it off into space, it's going to go by default to the origin. But when you place it, you do need a point. So you can select a point on your part, and then it's going to prompt you to select the x-axis first. And you do have to pick another point. So you can't do it on this line or anywhere that isn't a point. You're going to have to add in a point if there isn't one by default. And then it's going to prompt you for your y-axis. And that's how it's going to place it. And then you could go up to your parameters, and you could see once again that you have 3 additional parameters for that new point. And they are based off of that single point that you placed it on the cube. So when you set this one to 0, 0, 0, it goes by default since it to the origin because it was placed off into space. But this one, because it was placed on this point, it's 0, 0, 0 is this corner of the cube. And when additionally, you could see the 3 planes it created for itself and the 3 axes that it also created for itself with the center point that you placed it on. And you could use these for features as well. And you can also use them for constraints if you need to. I'm going to be showing how you could use it for a feature. So here on this handle that I have, that's based off of the real one that I had mentioned before, you could see that I'm missing a hole right here on this edge where the rail would go. So as you can see right here on my own part, there's a hole that goes right on that feature. You kind of see. And that is for a bolt to tighten this rod so it doesn't move. And we're going to go ahead and add that in. Let me get rid of my video here while I go ahead and show you. So there isn't a point on this face. We're going to need to add that in because the UCS works off of the point. So we're going to go ahead and create a sketch on this plane. I'm going to create a simple line, vertical line, place that, click on it, make this a construction line, and then create a point on that line. And this is what I'm going to be using to place my feature, my UCS. And then go back into 3D model. You could see I could use this point to place it. And I'm going to click finish since I don't have a defined X point or a defined Y axis point. I'm just going to place it and then select the UCS. Probably one of the hardest things about using them is selecting it. And then I can actually rotate this. So if I see that this isn't quite exactly the direction that I wanted, I can go ahead and just rotate it here. And that looks a little bit closer. I'm going to go ahead and finish that, but I can also edit that same rotation on the parameter right here. Right now, you can see I set it to 20 degrees, and that looks good to me. But if I did want it at a specific angle, I could go ahead and set that.
And so an interesting point with this too is that, that angle is specifically not normal to that incline, correct?
Yes. So as you can see, like right here, I'm going to go back to my presentation. I was able to place it on this dome feature, which doesn't have any defined features or axes that I could use.
Mm-hmm. Yeah.
And then create a skewed hole on that.
Mm-hmm. It's good to know too that a lot of, you can do a lot of stuff with other types of work features. Like, you could have possibly done like a rotated plane work feature or something like that to kind of compound all of them together. But what's nice about UCS is that it pretty much does all of that in a single click. And then you have the whole coordinate system with all of its XYZ planes easily defined that way, instead of going through making a point, making a plane, rotating another plane. So this saves a lot of time just for setting up any kind of relative orientation like this. Yeah, looks good.
Yeah, and like you said, I know I kind of place it haphazardly, but if I were to add some dimensions here, I could go ahead and move this, and then it would move the feature that I would add. So I can go ahead and go in here and close out of this bump feature. I can go here, select that point on the UCS, and then go ahead and select the direction, which I want to be the Y direction.
Oh, look at that. Yeah.
And then place that. And then I want to go up to surface, which will be the surface. And there's my whole feature. And like I mentioned, you can go ahead and move this around. I know I didn't really place it exactly for this demonstration, but if you had a dimension here, you could go ahead and move that. And then you always have these parameters that you could change within the UCS. So if I wanted to skew it a different way, it might mess it up, but rebuild the feature, but you can see rebuilds it if I needed to. Okay, so now I'm going to be placing 2 more on here. As you saw that little setup that I had shown, there is an additional part on top of here, and there's another one back here. So I'm going to create a couple other UCSs within this part. I do need a point on here, so I'm going to add a point for this circle feature. And then I need to add one more right in between these 2 circles. So what I will do for that is I'm going to create a new sketch on this plane, do a projected geometry for these 2 circles, and create a midpoint right in between them. Just connecting these really quick. Construction line, and then add a point right here on the center. Okay. And then I can add 2 more UCSs in here that I will use for my assembly. You have to make sure to also finish it. Otherwise, it'll just disappear. I just exit out of this without clicking finish. Okay, so there's my part. And this is going to be the main part for my assembly that I have open. I'm going to save that and move on over to my assembly, where you can see my 3 parts. I do have one more. These 2 I did add in the UCS beforehand, but this one I did not. So I'm going to go in here and add in another point on here and a UCS really quick. This edge, it might be easier if I did that within the extrusion itself. So I'm going to go here, edit sketch, and another. I just want to show the sketch to reference it. And place the UCS on a point on here. And now the sketch is in the middle, so I do want to offset the UCS a little bit on the y-axis. Up and down a little. And there. And that places it right on the bottom.
Yeah, you were telling me earlier, Marco, these are called NATO bars. Is that correct?
Yeah, so these are called NATO rails, and what these do is you can have a whole bunch of them on the inside of the part, this handle right here. You can see it has holes all around.
Oh, I see.
And those are place them.
Oh, I see. I see.
And these clamp on different camera parts. So right on the here, these are a standard way of putting these onto maybe a monitor or a microphone can clamp onto here, or another handle if you need another handle. And then you can see here, this is a hot shoe one, which this handle has a ton of them, but doesn't have any on the sides. So what I'm going to do on here is actually add one onto the side of it. So now inside of the constraint, you can see there is constraint set. This is where you can add a constraint where your two UCSs can join together, and you can see that it went ahead and overlapped them. And this is where kind of direction matters. You could see that I didn't quite set it up the way I wanted it. I wanted it to be going across it and not going along this. So I can go back into here and then edit the Y, change it, rotate it 90 degrees. Select it, rotate it 90 degrees, finish, turn, and then it's going to go ahead and rotate it. So that's very useful, being able to go back, edit them really quickly. Also being able to see them in the parameters, you can go ahead and edit them. None of them were placed within the assembly, so you're not going to see them in here. But when you do, you can also place them inside of an assembly, and I'm going to go ahead and show that in a little bit. I'm just going to constrain a couple more of these. So here, constrain that and that one. See, that one's a little rotated, a little funky, so I'm going to need to go ahead and change that. And then the last one, constrain this one, this one, this one. No, this one, wrong one. Need to place one on this hole right here. Go ahead and place back to the handle and quickly place one point and the UCS.
Yeah, it's interesting to note, because when you do the UCS to UCS constraint, like that's going to fix it in all three directions, correct? Like it's going to be completely fixed to that orientation.
Yeah. And so what I kind of noticed back in here is when I used a normal constraint between this and this axis on this one, if I go ahead and place that, you can see that it's kind of still moving in quite a few directions.
Yeah, absolutely. Yeah.
So,
and if you guys are familiar, like when you place a part in assemblies, you could right click and click grounded at origin is a common option that people start assemblies with. And that'll effectively fix the origin of that part to the origin of the assembly. Right. And that's a good way to kind of coordinate parts. And when we talk about best practices in Inventor, it often, we often start by saying, you should probably center your part at the origin if possible. Some people in chat are talking about how they have off axis or off origin UCSs, and it makes it difficult to constrain. Can you talk a little bit about that? What happens when a part's not centered at the origin, Marco?
Yeah, so go ahead. Reorientate that. Or actually, it needs to be reorientated a different way. But yeah, you can go ahead and, so if you want to place one, like I mentioned at the beginning, if you place it out into space, it defaults to the origin. So go ahead and place that one. And then you're going to see that one actually shows up under parameters here, and place that at 0. I can place another one within the part. Let's say if I wanted one down here, or if I wanted it to be somewhere else centered in here, and then I can go ahead and constrain them together. And that way, that new point that I placed it on here will go ahead and move over here. And then my whole part is set to the origin where I want it to be.
Nice. Yeah, like that's a really common question we get in Inventors. Can I change my universal coordinate system in my part? Which largely is no, but you can do this thing with the UCSs, the custom ones, where you can kind of just define a new center point for your part and then constrain it to where it needs to go. That's a really common one, yeah.
There we go.
Oh, look at that. It's a really cool assembly.
There we go. That's our little assembly there. And what I'm going to do now is actually create one more to show you how you can go ahead and use this to reorientate your origin, or just translate it differently. We're going to go ahead and hide some of these. They're getting in the way a little bit.
No problem.
Go ahead and hide that one. Hide this one. Hide a couple in here. Maybe turn that off. That one off. That one off. Kind of built a lot in here today. And now I'm going to go into the handle one more time. And I want my new origin to actually be at the bottom of this mounting point, which we call an RE mounting point. So I want this to be my new origin. So I'm going to create one more point on there. And this UCS, I actually want Z up this time. I know it is pretty common for, especially in boats or buildings, to actually have your Z going up. So I'm going to rotate this last one so that forward is, the front of the handle is actually the Z axis, and going up, there we go. And I can go ahead and change this as well inside of the parameters. I'm just going to go ahead and try to rotate it. Okay. So there we go. We have that one last UCS. Save that here. Go back to the assembly. You can see it is updated. Now, if I were to place it on this assembly, you can see that the origin is actually already facing this. Z-axis is coming out at us. So I'm going to go ahead and create a new assembly and rotate the origin so that way the Z-axis is up. I'm going to show these. I'm going to move my bottom to the side and set this as my front plane. I'm going to move this over here and set this as my home view. And I'm going to place the UCS out into space, set it to 0. And then place my assembly here, make sure this is saved. Go back in here and then place it. And you can see when I place it, the axis, because when I created it, the y-axis was up. It's a little rotated a little weird right now, but we can go ahead and create a new constraint and very quickly select our 2 UCSs, and it'll go ahead and go through that one actually. Go back to this one and select this one right here. That's a lot of that. Back here, this one, and the one, that one. Okay, and then just like that, we have a Z up. Go to our home view. This is one of the other ones that I had made earlier. You can see this one's Z up now, and you can do this in other assemblies if you need to move them over and reorientate your axis.
Very nice, right on. I know that'll be convenient for a lot of people. Yeah, it's a really common request.
Yeah, and then a great part is having this here. If you do need to move it forward or back, you can go ahead and change that origin UCS that we made and then translate it in a certain direction if you need to. So if I needed to move the x-axis forward, I can go ahead and do that in here. Or if I need to move it back or anywhere in the future. Go back to PowerPoint. All right, so we went over today kind of understanding what the origin creates when you open a part in an assembly, and then how you could use the UCS both in features and then using it in an assembly to constrain, and then even more specifically being able to use it within an assembly to reorientate your axis.
Yeah, I was going to say, yeah, the UCS to UCS constraint is kind of great because it does like it locks all those degrees of freedoms really easily. So as opposed to going through the three different axes and trying to lock constrain those, that's a really convenient time saver just in itself.
Yeah, and especially within like parts like these where they really are only mounted at one point.
Yeah,
I can make that in the original part, and then I don't have to go back in future parts, and then I
yeah,
can just place them in the future very easily.
yeah. I think that's a really cool example. Yeah, like that's exactly what when you would want to use UCSs like that. Um, and okay, and so do you have any other slides here? You ready to go to Q&A? Oh, beautiful. Oh, yeah, there we go. Of course, this is my slide. And so right before we get into Q&A, I do want to talk about a few upcoming events that we have. There's quite a lot of stuff going on here. And so I just wanted to kind of let everyone know. First off, we do have Autodesk Accelerate, which is kind of this event that Autodesk is holding about kind of have a bunch of industry speakers to talk about the kind of digital revolution, ways to automate and integrate your current workflows using the kind of, a lot of people are talking about cloud technologies, but automation and streamlining are a big conversation. And so if you could go to that link, the Join with KETIV link there, Marco, and if you don't mind just opening up that web page there.
Yeah, of course.
Beautiful. And can you do me a favor and actually copy that into the chat for everyone to use over there?
Yeah. So I went ahead and sent that in the Zoom chat.
That's perfect. Yeah. And so again, this is just like an online event for people if you're looking for more information about how to automate your processes or how to kind of take advantage of kind of digital solutions in the modern age. It's a big kind of conversation about efficiency and everything right now. And so that's highly recommend check that out. We'll have a table there as KETIV ourselves. And if you could minimize this window, that'd be great. We do have upcoming AVA sessions. I had mentioned CAM earlier, and I've had some people come to ask us like, how do we change the UCS for our CAM parts, which is a bit of a moot point. And we were talking about this just before the session, Marco. But oftentimes, if you are doing like UCS changing, like that usually gets done on the CAM side of things in the CAM software. So yeah, it is related, but we do have more conversation about PowerMill. We'll be doing what's new in PowerMill next week for the Thursday session. And the week after that, we'll be doing advanced iLogic, since I know some people are really interested in iLogic in this chat already as well. So I'm going to include that link here as well for you guys. I got you this time, Marco. I have the links ready.
Okay. Thank
you, though. And I'll paste that into chat for everyone to see. And that's for the AVA sign up. And then finally, this is a topic that came up that I do think is really interesting. We did an AVA recently about using automating assemblies, exactly. So not necessarily exclusively about UCSs, but it does iLogic does take advantage, and it is aware of UCSs, similar to how it's aware of other named features or work features that you would use to help automate assemblies and stuff. And I want to include a link for that for you guys as well. Give me a moment. This is a video that I've used recently as well, but this is a good primer for not just UCSs and iLogic, but just automation in general is a good bit of information in here as well. So I highly recommend we check that out. I think that's all I got for this slide. Let's go ahead and go to the next slide here, Marco. And Q&A. Let's see, what do we got going on over here? All right, let's double check chat. What's going on here? Cool, thank you. Okay. Yeah, at the beginning, we had asked for some uses for UCSs and stuff. And so some people are saying UCS to UCS constraining, very helpful for quickening your assembly time. Absolutely. Inlets, outlets on conveyors, also taking into account UCSs and extra margins over there as well. Yeah. Work features, work points, UCSs like this is all great. And you could imagine the implications for doing stuff like setting up your tube and pipe routing, for example, if you're doing factory assets with conveyors, inlets, outlets, that's fantastic. And Andreas, we had talked about the kind of moving the coordinate system. That's good stuff. API and iLogic have good plugins for this kind of workflow as well. Awesome. Can you email the links? Yeah, absolutely. No worries, Michael, I got you. And looking at the questions now, we got some from Eric over here. Can a custom UCS be used in an iPart factory? I believe so. Yeah, I mean, I don't think it's much different than just having a regular work feature like a plane or an axis. But have you tried using any of the UCS stuff with iParts, Marco?
I have not yet, actually.
Yeah, no problem. Yeah, I'm pretty confident it can be used with iPart factories, and I'm assuming it's going
Yeah,
to be really similar to work features in that regard, Eric. Yeah. And like I discussed already, it is very similar. It does get brought up in iLogic a lot, where this becomes an extra reference point where you could then start doing assembly placements, like talked about in that YouTube video. Actually goes into how to kind of constrain UCSs and set up relative positions for automating assemblies. So there is a lot of iLogic workflows there that are available as well. Can you use a joint with rigid options for some of these components? Absolutely. Yeah. And so this is an interesting one just because, every time you talk about assemblies, someone usually asks about joints and how that kind of
yeah.
fits into a lot of things. Have you used joints a lot already, Marco?
I have a little bit on these parts.
Oh,
It's
yeah.
really just a matter of how you want to constrain your part.
Yeah, absolutely. And so Brian Kelly had mentioned the rigid joint that's available, which does really similar stuff to kind of what we just saw, right? Because rigid is essentially just taking away all 3 degrees of freedom, all 6 degrees
Yeah,
of freedom. But joints have a slightly different implication in that, you have to choose these dedicated points of interest. But at the end of the day, they both take away the same amount of degrees of freedom. So whichever one's your preference really at that point. But anything to add on that, Marco?
no, that pretty much covered it. Yeah,
Right on. And then follow up from Eric as well, using joints a lot because you can orient the joints together, which is nice. And there's a flat face, but if you don't have a flat face or edge, it gets tricky. Absolutely. Yeah, we deal with a lot of round parts, fittings, flanges, and getting them oriented is a little harder. Can you use custom UCS and joints? I haven't tested that, honestly. I would have presumed so, but do you know, Marco?
I have not tested it in joints yet.
Yeah, because if anyone's unfamiliar with joints, whenever you use joints, it often prompts you to choose particular edges, faces, center of faces, and stuff like that without much, further granularity available. So I'm curious. I'm not actually sure if UCSs would show up there or not. I'm kind of doubtful because I don't think it shows up for other reference points in joints. But it brings up a good point just because in general, right, UCSs in a vacuum, you still need other stuff to make sure they work properly, right? So same thing with regular
Yeah,
work features. You could still use like a line and a point and a plane to kind of get to a relevant location, where then you could place a UCS like on a curved edge, for example, like you showed earlier. Sometimes you
yeah.
just need extra work features to do what you need to do. Sorry, were you going to say something, Marco?
No, no.
All right on.
Yeah.
Um, and so, yeah, I'm not sure how much further UCSs interact with joints, but in general, you still have to do some kind of setup with the other reference features to get any of this to work. And so I hope that answers your question, Eric. It's good stuff. Okay. And yeah, I guess any other questions? This is again, it's a super interesting thing that feeds into a lot of other interesting workflows. So we have definitely more. Plenty of more to say about this if you guys are curious. Um, yeah. Yeah. Okay. Let's see. Okay. Yeah. Any closing words here, Marco? Do you have another slide here? I think that's it,
No,
huh?
just
Perfect.
finishing up. Thank you so much for having me on here today.
Dude, thanks for coming on, man. Yeah, that was a cool example. It's good to bring you into the fold here, and hope to see more of you
Yeah.
in the future, man. All right. Okay. And so, yeah, I guess with that, thanks everyone for being on this session. Thank you, Marco, once again. You could expect a follow up with some more relevant information, including the links and the survey response as well. If you guys have any feedback, we were really curious about future topics as well. So if you have any ideas for future topics, maybe you want some more stuff on iLogic, maybe you want some more in BIM exports, maybe CAM, what have you, let us know, and we could get that stuff slotted into the schedule, no problem. All right. Thanks everybody. Have a good week, and we'll see you again soon. Oh wait, Q&A. Rigid joints are great. Okay, that looks good. I'm gonna